So in the previous session, in side distances, we have seen something called what? What are all the topics that we have seen in side distance topic? That is, we have seen SSD and side distance at intersections. Distance at intersections. In side distance itself, we have seen some other thing that is called as SSD at two-way traffic in single lane, that is SSD1 plus SSD2. Similarly here also SSD1 plus SSD2, isn't it? But if it was one-way traffic, sorry, two-way traffic, double lane, it will be simple. It is only SSD. You know it, right? So shall we proceed? Shall we proceed, ma? So in this topic, today's session, we are going to, this is 1 hour session. So we are going to try to complete overtaking side distance and intermediate side distance topic today. Okay. So in today's session, we are going to see what is called as overtaking side distance. What is meant by overtaking side distance, ma? When will you come across overtaking side distance? What is the necessity actually? Content, OSD and ISD. So see here, SSD we have seen, that is an obstruction should be visible to the driver, right? That was called as SSD from a certain distance, which is called as stopping side distance, because he has to pass, he has to stop before getting collided with the obstruction, isn't it? So what is meant by overtaking side distance? In overtaking side distance, this overtaking side distance itself occurs only when there is mixed traffic condition. Let us assume, see here, let us assume a lane like this. So this fellow, let us assume this is A and this is B. Okay, this fellow is moving very slow, that is, he, let us assume he is going some 70 kmph, but this fellow wants to, but A wants to go faster. He don't want to go in only same 70 km per hour. He will try to go in 70 km per hour, but even then the distance is very slow, the gap between them is very lesser. So what this fellow wants to do is, he saw this fellow for nearly 5 to 10 minutes. A has seen B for 5 to 10 minutes. He is going very slow, that is 70 kmph. This A has to go in 100 kmph, because this fellow is, his age is some less than 30. B age is some 60. 60 fellow will go very slow, right? Because they have seen so much thing in their life. That's why they will go very slowly and coolly. But this fellow has not seen anything in his life, right? So that's why he will try to go in a very faster way. So what he will do? He will try to overtake. Okay, when he will overtake? Only when there is some mixed traffic condition. Please don't remember this age. Okay, this I have told just for example. Okay, OSD occurs only when there is some mixed traffic condition. It means there is some slow moving vehicle, there is some fast moving vehicle, all those things. That's why, since there is the mixed traffic in the highway, we are going for overtaking side distance. We are going to study for overtaking side distance. Is that clear? If not, there is no need of overtaking itself, isn't it? If everybody is going on the same design speed, then no need to overtake, right? Somebody is going slow, somebody is going fast. So that's why we need to go for OSD in mixed traffic condition only. Is that clear? So shall we proceed? We'll see in animations everything. Okay. So see here. So see here, in case of mixed traffic conditions, very important. In case of mixed traffic conditions, It is necessary for fast moving vehicles to overtake slow moving vehicles. Simple. So the overtaking sight distance is the minimum distance open to the vision of the driver of a vehicle intended to overtake the slow moving vehicle ahead safely against the traffic in the opposite direction. Is that clear? Are you all getting the point? What will happen is, see here, okay, in previous slide I will show. See here. So in opposite direction also some vehicle may come, right? So before this opposite vehicle is approaching him, this A has to move to his original lane. Are you getting the point? This A is overtaking vehicle B, and to overtake, what it is doing, it is trying to come to the speed of B, and then it is seeing in the right lane, second lane. So it is seeing that there is no vehicle. So what his mind says, it says to overtake. So when he tries to overtake, he will come to the second lane, and then he will come to the second lane, and then he will keep on accelerating. He will move in a very faster rate because he has to overtake. Because when he is overtaking, when A is overtaking, B will not be in still position. B, it will not be in rest position. Okay, it is also moving. So A has to accelerate more such that it can overtake it and come again to its original lane, because in the opposite lane some other opposite coming vehicle is approaching. Is that clear? Before that, this fellow has to go to his original lane. Am I clear? See here, this is what we have seen here. This is the definition. So see here, don't directly remember the definition, understand the definition, so that you will understand. Only if you understand the definition you will remember it. If not, you cannot remember. Just by hearting you can't remember. See here, the overtaking sight distance is the minimum distance open to the vision of the driver of a vehicle intending to overtake the slow moving vehicle ahead safely against the traffic in the opposite direction. That minimum distance is called as overtaking sight distance. See here. So what is happening? See here. Got it? So before C is coming, A is going to its original lane. Again, see here. This orange car, see here. Let us assume orange car is equals to fast moving vehicle, or overtaking vehicle. It means this fellow is overtaking. Are you getting the point? Next, yellow car is equals to slow moving vehicle, or overtaken vehicle. Next, blue car implies what? Opposite vehicle. Got it? So we are representing orange car as A, yellow car as B, and blue car as C. Are you getting the point? So what this A is doing, A is coming in a faster way. Okay, it is coming in very high speed. When it intends to overtake B, what it does, it will come to its own speed. What? Yellow car's speed. Orange car will come to yellow car's speed, and it will see in the right hand side. That is the second lane. So if nobody is coming, what it will do, it will try to come to it the second lane, that is the right side lane, and it will accelerate in a high rate. Okay, when it accelerates, what will happen? If it suddenly sees the vehicle in the opposite direction, it has to go back to its original lane. Till that, B will not be in a still position, that is also moving with the velocity. Is that clear? So how is it going? See here, B is also going. A has seen, come to second lane, and it is going to the going back to its original lane. Is that clear? See here again, A is coming in the speed of B, and B is also moving. What A is doing, A is coming to its second lane and overtaking B, sees the blue car, and it is going to its original lane. Is that clear, ma? Everybody? Because the animations and all will not be visible in your PDF file. That's why. Again, got it clear? So shall we proceed? See here. So what is happening? Overtaking process on a two lane with two-way traffic movement. Two-way traffic movement when C is also coming. Okay. When there is when there is only single lane, what will happen? One car is going. This opposite car, you will not consider anything about this opposite car. Okay. So this fellow will come here. He will go. He will overtake, and he will go like this. Okay. You will not consider anything about C in single lane. Single lane, one-way traffic. See here, how is the overtaking process going on? See here, vehicle A traveling at design speed. Design speed, let us assume it is some 100 kmph, whatever it is. Okay, no problem. At design speed, desires to overtake slower moving vehicle. Slower vehicle B moving slowly at VB meter per second. This is going in VB meter per second, ma, very important. Okay. It means what is the overtaking? What is the speed of overtaken vehicle? What is the speed of overtaken vehicle? How are we representing it? VB. Very good. This is the overtaken vehicle speed. Overtaken vehicle. VB. Small. Everywhere in transportation engineering, small VB. V is in meter per second. Capital V is in kilometer per hour. Okay. Try to remember in that way. Okay. This is the speed of overtaken vehicle. Next, vehicle A has to accelerate, shift to adjacent right side lane, complete the overtaking operation, and return to left lane before the vehicle C coming in opposite direction approaches overtaking stretch. Is that clear? Is the point clear, ma? Next, A reduces. First, what is happening is A is coming in its design speed, but to overtake B, what it is doing, A reduces the speed to VB and it travels distance D1 during reaction time of small t. See here, what happened? See here, this is moving it, Anna. This has moved till here, right? See here. This is A. This is A. Okay. What A is doing? A is moving, and then it reduced to VB. Okay. A is moving at VB, and then it is accelerating. Is that clear, ma? Earlier, from here to here, it has come up with a speed of VA actually. So after it sees B car, what it is doing, it is reducing its speed to VB and it is moving along with B for certain distance and then it is overtaking. Is that clear? Here the vehicle speed is VB. This fellow is also moving in VB. Am I clear? Don't take VA, okay? Vehicle number A, VA. Please don't take like that, okay? Because see here, it is moving at a speed of that VB only for certain distance and that distance is taken as D1, okay? That is A reduces the speed to VB and travels distance D1 during reaction time of small t. Here in OSD, reaction time is taken as 2 seconds. It is not similar to SSD I have earlier mentioned, isn't it? Next, from A1 to A2, that is this one. Here is it. Yeah, this position to this position. This is A1 and this is A2. Is that clear? I'll represent. Next figure will clearly mention everything. Next, vehicle A accelerates and overtakes B within a distance D2 in time capital T seconds from A2 to A3. Time T is time for overtaking. See here, after coming here, okay, this orange is moving like this, right? Total this operation is called as D2. This operation is called as D1. See here, it has moved like this, it has come, it has taken its original length. Am I clear? Is this clear, ma? Till here it will be called as D2. Are you getting the point? That is what I have mentioned. This is A2 and this is A3. See here. Here. Vehicle A accelerates and overtakes B within a distance D2 in time capital T seconds. From why this is capital T and why this is small t? Because this is just reaction time to overtake. This is accelerating at a acceleration of A. It is moving at a very high speed. That time is called as capital T. How to calculate? We will see. Okay. Capital T seconds from A2 to A3. Capital T is time for overtaking. Is that clear? Next, opposite vehicle C is coming in opposite direction, right? That distance is D3. D3 is the distance traveled by vehicle coming in opposite direction in time. In this time, in overtaking, in accelerating time of A, how much distance this C vehicle is coming? How much distance C vehicle has covered? That is called as a D3 in time t seconds from C1 to C3. Is that clear, ma? Is that clear? Shall we proceed? Yeah. See here. This is what has happened. We shall derive everything. See here. This is called as A1. Okay. This is called as A2. This is called as B1. This is called as B2. This is called as A3. This is called as C1. This is called as C2. Is that clear? Is that clear, ma? So this vehicle A1 is moving at a speed of what? It is coming till A2 and then it is overtaking. It starts its overtaking operation here. Vehicle A is moving at what speed, ma? At A1 position? No, yaar. It is going with B, right? For a certain distance. Sapna, it is VB only, ma. We are considering VB that distance only. Okay, don't think that it is in somewhere else. This one only is VA. After coming to a certain distance, this is not necessary. How much distance is it is traveling with B with that speed? From that only we'll take it as distance. Okay, that only we will consider. All others will not consider. So therefore, very important, because in exam you will substitute that one VA and you will not get the answer. Answer will not be an option also, because nobody will use that option. This is VB. B vehicle is also moving at a speed of VB only, isn't it? Next, C vehicle is moving at a speed of VC. Is that clear? So it is moving at VB to a certain distance, and that distance is called as what? It is represented as what, ma? That distance is represented as what, ma? Should actually cut at the center to center position. That's why. Yeah. That distance is called as D1, right? Oh. Yes. Perfect. So let us take it clearly. This is called as D1, this is called as D2, and this is called as D3. Correct? Okay. So this A1 A vehicle is moving from A1 position to A2, and that distance is called as D1. Is that clear? Next, A vehicle is moving from A2 position to A3 position, and that distance is called as D2. Next, C vehicle is moving from C1 position to C2, and that distance is called as D3. And there is a point to remember here. See here, this vehicle, what it is doing here? This vehicle is trying to overtake. It is coming to the second lane, and it is overtaking like this. Am I clear? Is this point clear, ma? And this distance is called as VB at time capital T, because accelerating here, it is actual acceleration. Actual acceleration is taking place. That is, acceleration due to gravity is represented as small a. And this distance is called as minimum clear distance between two vehicles. Is that clear? Minimum clear distance between fast moving and slow moving vehicle, and that is represented as capital S. Is that clear? It is the minimum clearance between two vehicles. S implies minimum clearance between slow moving vehicle and fast moving vehicles, and it is taken as 0.7 VB plus 6 meters. This VB in meter per second. If you want to convert this VB into kilometer per hour, what you will do? You will multiply it using 0.278. That is divided by 3.6. That is, you will multiply by 1000 and divide by 3600. Is that clear? So how is it? How is this value coming? So see here. See here, ma. It is cutting half of it, right? and here there is half. And this distance, let us take this as x and this as y and this position. Are you guys getting the point? Is it visible, ma? This is, let us take this as x and this as y. And this distance is called as 0.7 vb. It means it will slowly move to the next lane. It will not fastly move to the next lane, it will move slowly. That is 0.7 times of vb. 0.7 times of vb it is taking. So therefore s is equals to 0.7 times of vb plus x plus y. This x plus y is the length of that vehicle. On an average, the length of the axle base, the length of the axle base is taken as 6 meter. Am I clear? That's why it is 0.7 vb plus 6. For all, 6 meter implies length of the vehicle. In exam, what sometimes what they can say is the length of the vehicle is 10 meters, they can say, or 12 meters they can say, and they can ask us the overtaking side distance. Then also you should not substitute the same 6. Okay, the value should be changed here. Is that clear? Shall we proceed, ma? Okay, let us find what is d1 first. d1 is equals to what? It is speed into time. So what is the speed it is coming? It is coming in vb. What is the time it is taken? It is taken t. Correct? Am I correct? Faster ma. We have to solve with non uniform acceleration also. Yeah. So similarly, next d2. d2 is actually this one, right? That is 2s plus vb into capital T. How to find this capital T? Okay, to find this capital T, there is an equation of motion. So you would have seen some equations of motions. What are they? S is equals to ut plus half at square. In physics you would have studied, or engineering mechanics you would have studied. Next, v is equals to u plus at. Correct. Next, v square minus u square is equals to 2as. Is that clear? So in this, you are going to use that first equation, that is s is equals to ut plus half at square, because distance only you know. That's why this is called as distance. So this is equals to, got it? So this is equals to ut plus half at square. So therefore 2s plus vb capital T is equals to, what is initial velocity u here? It is vb only. Correct? This VBT and this VBT gets cancelled. Please say me what is capital T here. Root of 4s by a. Isn't it? Am I correct? Where s is in meters, a is in meter per second square. Understood? Next. D3. D3 is equals to what, ma? D3 is equals to VC into capital T, because he is also moving in a very fast only, because no vehicle, no, what to say, no vehicle is in front of him, because that's why he is going in a very faster rate. Till this capital T, till this acceleration time, this fellow is not coming, right? They are not. If he is coming, then both A3 and C2 position will get collided, conflicted, isn't it? So therefore, OSD is equals to D1 plus D2 plus D3. Got it? Note, note. If VB is not given, then that is equals to VA minus 4.5 if it is in meter per second, or VA minus 16 kmph. If VB is not given, they will say at least A is moving at a design speed of 100 kmph. So therefore, what is slow moving vehicle? What is the speed of slow moving vehicle? You can say it as minus 16, that is 84 kmph. That's all, like that. Is that clear? This is called as overtaking side distance. Shall we proceed? Yeah. So see here, on mild gradient, these are all points you have to remember. On mild gradients, there is no need to provide, there is no extra distance for what to say, ascending and descending gradients. Here, on mild gradients up to ruling gradient on plane and rolling zone, OSD at both ascending and descending gradients are equal to that of level roads. So therefore, no, we are not considering anything about that gradients. That is what to say, 0.01 n and all will not come in OSD. But at steeper gradients, you have to provide little greater than OSD. That the minimum OSD, that is D1 plus D2 and D3, when you add, you will give more value when compared to this one when it is steeper gradients. Next, on roads with two-way traffic, two traffic movement, minimum distance is this one. Single traffic, see here, on divided highways, see here, let us assume there is a divider provided here, okay, and vehicle has to move like this. Then this fellow will move like this, right? That's all. No need to consider anything about this C1 and C2 and all, right? C1, C2. This distance is not necessary. Am I correct? Since this is divided, we no need to consider that that D3 position. So this D3 gets cancelled here. Are you getting the point? On divided highways and roads having two-way traffic. Okay, D3 will not come. Next, on divided highways with 4 or more lanes, if there are 4 or more lanes, there is no need for overtaking. Okay, overtaking side distance is no need to provide. Am I clear? Shall we proceed? Shall we proceed, ma? So therefore, OSD is equals to what? It is VB into small t plus 2s plus VB into capital T plus VC into capital T. Correct? So everything is in meter per second square. For all, T is equals to root of 4s by A. Next, OSD is equals to 0.278 VB into small t plus 2s plus 0.278 VB into capital T plus VC. 0.278 VC into capital T. Got it? Got it, ma? Shall we proceed? There is another point we have to see, overtaking zone and all. See here. Next. What are all the factors that we have seen? See here. The factors on OSD depends on, see here, height of driver's eye above road surface. It is 1.2 meter. Whom you are going to overtake? Are you going to overtake the obstruction? Are you going to overtake the what to say, animals like cat, rat, and all? No, you are going to overtake the vehicle only. So here the object is also considered as vehicle. That is, height of object above road surface is also 1.2 meter. Next, you have to consider speed of overtaking vehicle, overtaken vehicle coming from opposite direction. Next, skill and reaction time of driver, that is 2 seconds. Next, minimum spacing, that is called as S, isn't it? Next, rate of acceleration, this is A. Next, gradient is not so important. That is, for milder gradient you no need to consider. Okay, gradient is not so important in OSD. Better take it off. It should not come in OSD. Okay. Next, overtaking zone. So here, see here, if this is like this, if the stretch is like this, when this fast moving vehicle should overtake, if the stretch is like this, there is no place for him to overtake, right? So if this is going for such a high distance, in highways what they will do is they will provide some overtaking zones, such that they will say that now you can overtake. Here there is no, it is saying that the sign is saying that overtaking sign is prohibited. This is overtaking prohibited sign. Is that clear? So when overtaking is allowed, there will be a post saying that overtaking zone starts here. See here. Now let us assume this is the lane. Okay. So what is happening is, so when it is moving in this single lane, there is no possibility for the vehicles to overtake. So that's why what you are doing is, before the overtaking zone starts, you will provide a what? You will provide a signboard saying that overtaking zone starts. Starts. So what is this? This is called as informatory sign. Got it? They are passing you some information saying to overtake. Next, here they will provide overtaking zone ends. Saying that, Abe, what are you doing till now? You have to overtake now. Okay, you can't overtake after this. This is what they will say. This is what is the meaning of this post. Overtaking zone ends. It is cautionary sign. There are three different signboards in what to say, in traffic engineering we shall study. Okay, this will be from, this distance is 1 OSD, this distance is also 1 OSD, Okay, and this distance is 3 OSD. So when you add all, it will be around 5 OSD. This is called as desirable length of overtaking zone. Got it? Next, this is called as minimum length of overtaking zone. Is that clear, ma? Because we have to start non-uniform acceleration also. Overtaking zone. Is that clear? See here, minimum length of overtaking zone is 3 times of OSD. That is 3 times of D1 plus D2 plus D3, or 3 times of D1 plus D2. This is for divided, and this is for opposite coming vehicle. And this is 5 times of D1 plus D2 plus D3, or 3 times of D1 plus D2. Understood? Is that clear? Yeah. Shall we proceed with a point called as overtaking with non-uniform acceleration? See here, in this, we, we said that this vehicle is going at a same acceleration throughout this, what to say, throughout this overtaking. Throughout this overtaking operation, we have seen that the acceleration is same. Is that clear? Correct? But what if that fellow A is wants to accelerate more? That is the case. Here, he may accelerate more like this. After this, he wants to accelerate. Then what to do? It means what? That D1 and D3 positions are going to be the same. But this D2 position alone will change. See here? Actually, it should move like this. But see here. After the D1 position and D3, excluding that D1 and D3 position, we are taking only D2 position. See here, only 3 cars, 3 orange cars, 2 yellow cars. This is an extra position saying that acceleration has changed. Shall we proceed, ma? Is that clear? Is the point clear? All of you? So this is actually the position of what? This is A2 position and this is A3 position, right? A2 position, this is A3 position, correct? Now there is another new position called A4 position. Okay, this is actually simple logic B1 and B2. All of we know it, all of us, isn't it? So let us take this one. So what is this A2 doing? He is going at a speed of VB. B1 is also going at a speed of VB only. So he is overtaking. He is trying to go to the next lane. After going to the next lane, he thinks that we shall accelerate more because he has some music on his car. So with that mood, he is trying to move in a very faster rate. Let us assume like that. Are you getting the point? So this one, he is going at an acceleration of a1 and this one at a time small t1. Is that clear? Is that clear, ma? What I'm trying to say? Let us assume this distance and this here he is going at an acceleration a2 and at a time t2 to reach this position, to reach this a3 position, a4 to a3 position he is taking time t2, and to reach from a2 to a4 position he is taking t1. This is different, this is the conventional type. If sometimes what if this acceleration changes, this you will not find in most number of books. Okay, try to understand. Okay, he is going at an acceleration a2, and a2 to a4 he is going at an acceleration of a1. Let us assume this distance as d2 dash and this distance as d2 double dash. But actually the clearance distance is same, right? That is s only. This is s, this is also s. What is this value, ma? What is this distance? This is simple, that is vb into t1 plus t2. It is not vb into capital T, it is vb into t1 plus t2, because t1 plus t2 will give you capital T only ultimately, isn't it? So therefore, what is d2 dash? D2 dash is equals to what, ma? Please respond. What is d2 dash? Please respond faster. It's based on the formula, that is ut plus half at square, right? Yeah, okay, good. That is v2 t1 plus half at square also, ma, because he's going at an acceleration of a1, right? Of a1 t1 square. This v2 is actually what? vb t1 plus half a1 t1 square, correct? Is that clear? Next, please say me what is d2 double dash. Faster. What is this distance? d2 double dash. What happened? Yeah, it is v4 t2 plus half a2 t2 square. Very good. What about this v4? Here v2 is equals to vb. v4 is equals to, so same, vb into t2 plus half a2 t2 square. Is that correct? Is that correct? Yeah, of course it is 100% wrong. This one is wrong, because he is coming here and he is accelerating. It means he is going in a higher speed, or maybe lower speed also. Let it be anything, some different acceleration, right? When it is moving in a different acceleration, this vb also has to change. So this v4 has to change. So therefore, what is v4 value? V4 is equals to, we have come up with a formula, V is equals to U plus AT, isn't it? So the same formula, that is V4 is equals to VB plus A1 T1. Is that clear, ma? Is that clear now? Is that clear? Yeah. So therefore, what is the value of D2? D2 is equals to D2 dash plus D2 double dash. That is equals to VBT1 plus half A1 T1 square plus VBT2, sorry, V4T2 plus plus half A2 T2 square. Or you can say it as S, sorry, better 2S, right? Better it would be S1 and S2. S1 plus VB T1 plus T2 plus S2. Is that clear? Now, are you guys confident enough? That is, you, if you have, even if you have non-uniform acceleration, you are in a position to solve the question. Okay. Done. So if what is intermediate side distance? Intermediate side distance is nothing but 2 times of SSD. That is, whenever there is no possibility for you to provide OSD, overtaking side distance, then you can go for SSD. That is, at certain stretches of roads where required OSD cannot be provided, intermediate side distance has to be provided. It means what? OSD is going to be greater than ISD is greater than SSD. Is that clear? If you cannot provide OSD, then you will go for ISD. But ISD is 2 times of SSD. Okay. Shall we proceed? I guess you can solve one question. No need summary. Okay, this question is a little tough. Yeah, please solve this question, ma. At least this question for this 5 minutes. Faster, faster. Faster, what is the answer? Faster. Yeah, faster. In today's evening session, we shall solve more number of questions and then we shall proceed with horizontal alignment. Okay. We shall try to solve all camber, SSD, OSD, ISD, all problems today. And then at least for 1 hour. After that, next 1 hour we'll start with horizontal alignment. Please solve, ma. Faster, ma. Faster, ma. What is the S value you are getting, ma? What is the value of S? Yalla. What is the value of S you are getting? Faster. 64.8, huh? No, I guess no. The scheme, I guess it's wrong. 25.46. No. See here, this VB is 84, ma. This is 100 minus 16 because they have not given slow moving vehicle speed. So it means what you have to do? You have to take minus 16. Fatima, please see. Please check and see me. So it is nothing but 0.278 into 0.7 into 84 plus 6. Now please respond. Yeah, now somebody is getting the answer. Yeah. I thought of taking calcium. Good. Okay. Now I guess it is 22.8 meters. Okay, no issues. 22.35. Okay. So it is 22.35 meters. Very good. What about T? T is equals to root of 4 into 22.35 divided by 0.53. Please respond. What is T value? Please respond. What is T value? 12.98 you are getting. Chalo, okay, no problem. Good. So T is equals to 12.98 seconds. Very good. So now please say me the answer ma, of OSD. Substitute here. All these values substitute here in equation number 1 and get me the answer faster. What is it? So 's value you got, right? Faster. Faster. That's all. Today's session will close here. Fast. Fast ma. Oh. Yeah. So you guys got it. So 750 meters is the correct answer. That's all. So 755.356 all of you are getting. So you are taking, yeah. Fatima, the thing is, for SSD the reaction time is 2.5 ma, but in OSD we have assumed it as 2 only according to IS 456. See here, I have mentioned. I guess you didn't catch it here. I have mentioned it clearly. For OSD it is 2 seconds. Got it? So answer is 750. You can go with option B. So that's all for today. In the next session we shall study something called for 1 hour we shall try to complete all problems from side distances, and then we shall proceed on horizontal alignments today's evening session. Is that clear? Okay, shall we close the session? So thank you all.